Hello everyone and welcome back to the channel. We have talked extensively about caching and its magic for speeding up applications. But what happens when your application grows so large that a single cache server or even an in-memory cache on one application instance just isn't enough when your datasets exceeds a single machine's RAM or you have thousands of concurrent users? You hit a wall, okay? This is where distributed caching comes to the rescue. Today, we are diving into what distributed caching is, why it is essential for large scale systems, and how it fundamentally changes how we think about caching. Okay, so let's answer the question about what is caching. So, at its core, distributed caching is a system where cached data is spread across multiple network instances rather than residing on a single machine or within a single application's memory. And instead of one cache holding all the data, you have a cluster of cache nodes, each holding a portion of the total cache datasets. It's like you can think of it like this: like we have a local cache is like a single node on your disk, fast access but limited space. Or a distributed cache, it's like a massive interconnected library where different books, which is the data, are stored in different sections, which is the cache nodes. But you have a smart system to quickly find any book you need, no matter which section is it's in. This distributed caching allows your caching layer to scale horizontally, handling massive amounts of data and thousands, even millions of concurrent requests that a single cache server simply couldn't manage. So basically, it will be pretty simple application. So we have here our apps. Like let's say that we have different services and a lot of different instances, and we have our DB, our main database. And here we have a cache cluster. We have distributed cache. So we don't have only one cache node. We have cache 1, cache 2, cache 3. Basically, we have a cluster that acts as one single unit. So when the app needs to read some data, it will read it from the nodes that it's connected to, or maybe there are the node replicate data to other nodes, so the data will never be lost. So once the cache has the data, it will send it back to the application. If the cache doesn't have the data, if we're using like a cache aside strategy, the app will retrieve the database, the item from the data, and once it get back, it might store it back in the cache, or might the cache handle all the write and the read to the database by itself. It depends on what strategy are you using. Okay, so why is distributed caching essential? Distributed caching becomes an absolute necessary for modern large-scale applications for several massive reasons. Number one, massive scalability. It breaks the memory and the processing limits of a single server. You can add more cache nodes to increase total cache capacity and handle more concurrent requests as your application grows. Number two, high availability and fault tolerance. If one cache node fails, the rest of the cluster can continue to operate. Data can often be replicated across multiple nodes, ensuring that even if a node goes down, its data is still available from a replica. This prevents your entire caching layer from becoming a single point of failure. Number three, data consistency across services. In a microservices architecture, where multiple independent services might need to access the same cache data, a distributed cache ensures all services see a consistent view of that data, as they are all talking to the same shared cache layer. Number four, shared state. Distributed caches are often used to store shared applications state, like user sessions across multiple web servers, preventing users from being logged out if the request hits a different server. Lastly, reduced database load. By handling significantly larger volume of cache hits, distributed caches further reduce the load on your primary database, allowing them to focus on write operations and complex queries. Okay, let's try to understand how does it work. So, implementing a distributed cache involves several key concepts. Number one, data partitioning, or basically hashing and sharding. Since data is spread across multiple nodes, there needs to be a mechanism to decide which node stores with which piece of data. First, we have consistent hashing. Think about that. This is a very common technique when an application requests data for a key. A hashing algorithm determines which node the key belongs to. Consistent hashing also minimizes data redistribution when nodes are added or removed, improving efficiency. Number two, range-based partition or sharding. Data might be partitioned based on range of keys values, similar to database sharding as well. Number two, replication. To ensure high availability and fault tolerance, data stored on one cache node is often replicated to one or more other nodes in the cluster. If the primary node for a piece of data fails, a replica can immediately take over. Number three, client-side awareness. Distributed cache client libraries are smart. They understand the cluster topology and can directly route a request for a specific key to the correct node that holds that data or its replica. This avoids needing a central proxy, reducing latency. Lastly, auto discovery and management. Modern distributed caching systems often include features for auto discovery of nodes, automatic rebalancing of data when nodes are added or removed, and built-in monitoring tools. So what are the challenges of distributed systems? While powerful, distributed caching isn't without its complexities. So first, we have increased complexity. Setting up and managing a distributed cache cluster is significantly more complex than a single node cache. You're dealing with networking, data partitioning, replication, and fault tolerance. Number two, network latency. Even though it's fast, requests still travel over the network between your application and the cache nodes, which introduces some latency compared to purely local in-memory cache. Number three, data consistency. Ensuring cache coherence or cache consistency across multiple distributed nodes is a significant challenge, especially with concurrent writes. Strategies like write-through cache invalidation messages and pops up or something like that, and careful time-to-live management become even more critical to use for data consistency. Number four, operational overhead. Monitoring, patching, scaling, and troubleshooting a distributed cache require dedicated operations and expertise. Lastly, cost. Running a cluster of cache servers naturally incurs high infrastructure costs compared to a single server. So, in conclusion, distributed caching is an indispensable technology for any application aiming for high scalability, availability, and performance. By distributing your cache across multiple servers, you overcome the limitation of single node system, handle massive data volumes, and serve millions of concurrent requests with lightning speed. While it introduces architectural complexity, the benefits for large-scale, high-traffic systems are huge. It's the key to making your data access truly elastic. That's it for this video, and see you in the future.